Okay, hello everyone. Welcome to the session of book club. So this is a new series of book club, and this in this series we are going to start with the new book clean code. So this is the first session. So I welcome you all. Thank you for joining in. Um, so yeah, uh, before I start, like, have you guys, how many of you have read the first introduction? Did you guys get a chance? Or okay, no issues. Okay, so yeah, let's discuss my understanding of the book, about what I understand after reading the first chapter of the book. Feel free to interrupt me at any time, and basically it will be a good session if it is interactive session. And as we will see uh, in the book, the author has mentioned that basically this clean code, uh, it it is also a lot about individuals' opinion. So people might have different opinion about clean code, like system design. There is no one absolute rule of what is the right system design. Similarly, there is a no absolute rule of what clean code are. There are some fundamental techniques which has proven to be good, and they help you write good code, but there could be some other techniques as well which could be good as well, right? So that's why feel free to jump in and feel free to interrupt if you don't agree with something or if you have some other opinion. And basically that's the overall purpose of this book club, right? Having that discussion and having and sharing those thoughts. Okay, so with that in mind, so let's begin. So before just the introduction chapter itself, like the author has mentioned one of this diagram. So the question asked was, what exactly is the measurement of code quality, right? How will you measure if you have to measure? So what the author has said is that it's basically what the fucks per minute. So what that means is that if you look at these two code reviews, right? So if looking at the code, reading at the code, if you're thinking in your mind, oh my God, what has this writer of the code has written? What is this? What is it? The more you feel about that code, the more bad that code is. The less you feel, the less you have that feeling about the code. That means it's a good code, right? uh, so now, like two, then the other thing is that there are two parts for learning any craftsmanship, right? One is knowledge and other is work. So knowledge is having the knowledge of what are the principles and what are the patterns that are to be followed when you want to create a craft. And then the other thing is work. Then you have to apply that knowledge and apply that work in practice to actually learn that craftsmanship. So one of the example that was mentioned in the book is let's say if someone explains you theoretically how to ride a bike, and he explains you all the laws of physics and basically tells you that this is the way how you ride the book. So you have the knowledge, right? But still you cannot ride the book. You cannot ride the bike unless you actually practice it, right? So this is where the work comes in, that now you have the knowledge, you have to work on it, and you have to apply it on your day-to-day life, right? So that's why the author has divided the book into three parts. That this first part is will be discussing principles, which is actually the knowledge of these principles and patterns that we need to follow. And then as a part of work, uh, that is something that we would have to do, but also author has given some case studies. So those case studies are some practical examples of how these principles were applied and how these principles made that bad piece of code into a good code, right? And then finally, he has some summary of what, like how these case studies were made and overall summary of the book, right? So these are the, this is how the book has been divided. And he has focused a lot that don't miss this second part, case studies. Like if you just read the principles, it is just like you are reading a feel good book that you are just feeling good. But unless you actually understand that in practice and from those examples, you won't actually learn that much, right? So that was what he wanted to tell. Yeah, so that was it. And then the next part was introduction. So before I move to introduction, anyone has to add anything? Cool. Okay. So yeah, anyone was saying? Okay.
Abhishek,
Yep.
can you elaborate WTF?
Okay. So like, so clean code, like what the author means to say is that, like sometimes we are reading some code, right? And like we, when reading the code, we see that why that person has done like this, it could have been done in this way, or why has he messed the code so much, right? Or like, I don't understand this, why he's doing it like this, right? So all those moments, like when you see a lot of those kind of, like when a lot of those thoughts come into your mind when reading that code, then that could probably mean that code is not written very well. Whereas if the code is written very crisp and clearly, uh, which is very easier to understand, then you will, that is a definition of good code.
Okay, okay, Abhishek.
Okay, so I, sorry, I'm not monitoring chat. Okay, yeah, cool. Okay, I'll open it on the other window. Okay, great. So yeah, so so the introduction, right? Like I have divided into four parts. So these four parts, right? So first, we we will discuss that why are we actually having this discussion? Uh, do we actually, like in future, if we think future of systems, will we actually need to write code, or we would be just able to replace code by AI, right? There are a lot of, like lot of these thoughts that maybe we can replace code by AI, right? So like an example, you can talk to your assistant and he can do something on your behalf, right? So basically your assistant is maybe converting your speech into some code and executing it, right? So in future, as these things develop more, maybe we won't need to write code as much, right? So that is this discussion. Then second, then we will discuss, okay, if we have to write code, then why is clean code important? If I'm focusing too much on writing clean code, then won't it slow me down? Like, because like obviously I would have to give more thought in writing the code, and I would have to write it more carefully. So, but in my organization, I have these deadlines. So how will I meet the deadlines, right? So we will see that why is clean code actually important. Then let's say after this second point, we all agree that, okay, we, although we have to meet the deadlines, still we need to write clean code. Then in the third, we will discuss that, uh, okay, so now we understand that clean code is important. What exactly is clean code? Like what, how will I say that this is the clean code, right? So so one of this definition was this, right? The above. We will see like some more details, and like this above was more abstract, and maybe we'll go in a little more detail over here, but still it will still be an abstraction. And then the fourth part, then we will understand, okay, now this is clean code. How do we actually go about writing clean code, right? So let's begin. So let's start with the first question, that do we need to write actually code, or can it, like in futures, do you guys think that maybe like, so as we are moving into abstractions, and as you can see, right, if you would have to write code in C++, you would maybe have to write a lot more line, or if you would have to write code in that in the at the system level, you have to write a lot of lines of code if you have to write machine code, right? And as your languages are becoming uh, much more convenient to write, that same expression could be expressed in much fewer lines of code, right? So do you guys think that eventually there might be a possibility that we don't have to write code at all?
No, but you need to tweak the existing code at times according to the requirements, right?
Mm-hmm. We would have to yeah, uh, yeah, but like, could we not just say like, yeah, you're right, we have to express and change those things, right? So basically what the author is saying, that the level of abstraction of a language will continue to increase, right? So level of abstraction means that you don't have to specify as much details as in lower level language that you have to provide. You can just abstract out and provide that information, and then language will handle it and take care of it. So that part will increase, but still you would need to write code, because basically, what is code? Code is actually a precise written down explanation of what are the requirements that we want our computer to fulfill, right? So even if we are not writing code, even if we are saying something to the machine, let's say in verbal language or something, we have to actually express it, right? And uh, basically that expression itself is writing code, right? And so for AI, right? So AI these days, like your assistants and all, they do these simple tasks. But like if it's a complex task, then your instructions will also be more. Your verbal instructions will also be more. And basically that itself is code, right? Whatever those instructions are that is code. So like you would have to write that code, you would have to write that explanation of what requirements you expect your computer to do. Like computers will never be able to understand vague ideas, right? Even humans itself, with all their understanding and creativity, they can't understand vague things, right? So computer, they can't understand vague things. They need that clear, well down set of instructions that they need to do, right? So that is code. And so this is another great line I've found in book, that so basically well specified requirements are as formal as code, and they act as like your test. They act like the test for your code. So from this, like the learning I got is that basically having, like whenever working on a project or something, like sometimes we tend to jump into writing code, or jumping into going into actually executing it before actually fully understanding the requirements. So your code is actually writing down those requirements into the steps how you want to do it, right? So understanding those requirements clearly is like more than half of your work done, right? Because that is what your code will also be. So, and your requirements, like whatever your requirements you have, you can just write down the unit test for it, that this is what my system should do, and then you can start writing code for it. And this is basically what the test driven development is, right? That you are first writing the unit test of what you expect your system to do, and then you start writing code, and then seeing whether your system is doing that you want it to do or not. Cool. So Nishit had some points. So Nishit mentioned that old technologies can be replaced with automation. There will be new technologies which needs code. Uh, and then he gave an example that web development is now automated, but blockchain needs coding. So basically, like a lot of things in your web development, you can drag and drop and do that stuff, right? And basically, it will execute that. It will write the code on your behalf. So you just drag and drop those elements, and then it will write the code. But according to me, like my understanding is, so in your web development, when you are giving these instructions that this element should be here, this element should be here, all those instructions, laying down that instructions is also one form of basically actually writing some code, and that code is maybe in a UI language, that your code lives in UI, that in UI you're specifying here, 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 everything should be there, but it is actually specifying code. Cool. And adding Ayush point, as the functional languages develop more, the level of abstraction will increase, but still to execute functional language, we need to write code, right? And yeah, that's an absolutely great point. Okay, let's move on to the next part. So why clean code is important, right? Won't it slow me down? How will I meet the deadline, right? So this question. So so the author is saying that if you have bad code, right, your your productivity will exponentially decrease with time. If you have bad code, as the code becomes more bad with time, this is how your productivity graph will look like. And so one thing like we all would have faced is that we often have pressure from our managers or from program managers that we have these deadlines and we want to finish coding within this deadline, right? But like what author is saying is that, so these program managers or your managers, they may not be well versed with what things needs to be done and how exactly the code needs to be written. So it is your responsibility to defend uh, and say that basically it will take this much time, and to properly do things it will take this much time, because they are unaware of it, right? They have some that high level abstract understanding of how long it will take, but you should be able to justify it, and you should be able to express that doing these things it will take this much time, so these deadlines are totally like won't be able to be met, and so we need to think about it, right? And in most organizations, if you are able to clearly express it and if you're able to clearly justify it, people will do agree and people will like let you take your time to write clean code. What do you guys think about this idea? So another thing is that like sometimes we feel that writing good code would slow us down, but writing bad code will actually slow us down instantly. So like one of the example I was thinking in my mind is like sometimes when I'm quickly doing a prototype or when I'm writing something quickly, right? And those hard coded strings, right? I will put them in line in the code, right? Let's say if there was some connection string, I will put it in line, right? And immediately, like after like sometimes let's say after few hours, if I have to change that string, if I have to update the URL, I will immediately start feeling the pain that I have to find that string and I have to see like where it is and then replace it. Whereas if it was on the top of my class as a constant or if it was in a config, like it's like it will be super easy to change it, right? So like you will notice that although it feels that writing clean code slows us down, but once we have that habit, once we go into the rhythm, we will see that like actually it helps us write code faster. And in fact, bad code is what actually slows us down, right? And I have seen sometimes that I'm writing bad, if I have written bad code, if like I have written that code, if after a break or if next day, if I'm looking at code, I'm myself taking time to understand what code I have written, right? And in place of that, if I've written good code, it's super easy for me to understand it and look at it even after a week also and understand what I was trying to do, right?
Yeah, this is super cool. So one example from my experience, Abhishek, uh,
Mhm.
as I write some code for infrastructures, like if I start writing something horribly wrong from the beginning, what
Mhm.
happens is it becomes a snowball towards the end. And
Yeah.
like you will never have time to clean this mess up. Never, ever. You would
Mhm.
want to eventually blame the timelines and then
Mhm.
try to sneak out from the situation. But yeah, it totally happens. And then all of us do that, I think, at some point in time.
Yeah.
So this is very good thing that I'm seeing here, and I think I'll try to stick to this.
Mhm.
As a principle, yeah, I think it's a good thing. Like it's worth
Yeah.
putting it, as a sticker in front of your desk. So yeah.
Yeah, definitely. Because yes, sometimes like are those habits, if we are not in that habit, then probably we might jump into like doing things fast and not in clean way. And as you mentioned, so maybe like having that sticker on your wall that no, it will slow you down, that will remind you again and again that no, you should
Yeah,
not
take
do it
time.
like this.
I
Yeah.
remember I remember becoming a rock star
Mm,
by doing stuff in less
mm,
time, but
mhm,
really doing it in a horrible fashion. Just because, okay, my manager is a little bit aggressive and asking me to, okay, me to get this shit done by end of this
mhm,
week. And okay, this can be done. This can be done. I can get you a half-baked sandwich, but I never
mhm.
tell this to my boss. Uh,
Yeah. Mhm.
that's gonna be how big. So it
Yeah.
happens. So I think yeah, it's a good thing where you can have arguments and you can be really
Mhm,
find a balance basically there and
mhm,
it's good.
mhm. Yep. Okay. Great. Thank you for sharing this. Uh, any other thoughts?
Yeah, I want to add a point like writing a clean code is more about like a habit. So the sooner you develop that habit, it's going to help you and your team in the long run.
Mhm,
And so, as my experience when I started initially, I wrote a really messy code. So it was a web API, and you need to like there were several components. I didn't write the modular code. So
mhm,
usually in JavaScript, you have those functions, and you can put them. So one thing is like you can divide your functionality into two or three functionalities, and
mhm,
later it becomes quite easy to debug if suppose a new use case comes or whatever. So it's better to divide the component into multiple components so that it becomes easy. Like you need not go through line by line 100 lines of code. You can divide it into chunks of 25 codes or maybe separate files. So that's really important, I think, in the long run.
Yeah. Yeah. That's a very great point. And yeah, and just to add, not even in the long run, like within like weeks or so, if you're debugging it, you will start to find the difference that if the code is not so great, you will feel the pain in debugging and understanding what you have written.
Yeah,
So yeah.
while debugging also, like you are going through the same bunch of code which is not required. You can check
Yeah.
the function and you can move ahead. So
Yeah,
it's
exactly. Yeah, yeah. Awesome. Okay. Yeah, and I think in the book, like author has given examples of where like how some companies they initially started with a product which was very great and customer liked it and they released the product pretty soon, and as the requirements started to add and basically the code started to become more muddled and more worse. And eventually, like after some time, developers were not able to handle that code, and their productivity was actually dipping so low. And so that project had to be shut down. So yeah, so there are a lot of those examples where if the things were not done initially great, then the later we had these issues. So another thing I want to add, which I just got reminded. So there is this another book, Pragmatic Programmer, and the author has also mentioned one of the concepts from that book. So what that book has has a philosophy of this broken window, right? So let's say if on a street we have a house, right? And if that house is completely clean and everything is clean over here, right? If you are walking past by that road, by that house, you won't be tempted to throw anything or something near the house, right? But let's say if you are walking down by a house which has a broken window, and basically it has not been taken care of, so like someone will see, oh, this house is not taken care of, it has a broken window and it's not taken care of, so it's okay, like I can also throw something here, right? Then other people, so there will be more trash over there, then some other people will pass by and they will put, and eventually it will that place will become a place where people are just throwing trash, right? So stopping that first flow of broken window is very important, right? So similarly in our code, like if we like we have to be careful that we don't have to let that first piece of bad smelly code entering in the system, because if you are saying that for to meet the deadline I'm going to write this bad piece of functionality, then when other developers or other people will see that code, maybe they might also be tempted to see that, okay, like people in here don't care about the code, so why should I put the effort? Okay, let me also write bad code, right? So and then your bad code might keep on accumulating, whereas if you are joining in a code where everyone is super careful about the code, then you will also, whenever you're sending your code reviews, you will be super careful about writing good code and making sure like it meets the bar of what your team is writing, right? So yeah.
We share some complicated.
Yeah, go ahead. Hello.
No, some random noise it was, I think.
Okay, no problem. Thank you. Okay, so now we understand why clean code is important, right? So what is the definition of clean code? So like, and the author has mentioned like a lot of definitions from lot of authors of various books. If we have time, we can go through them. Like one of my favorite things which was mentioned here is this. So basically, bad code tries to do too much. It has muddled intent and ambiguity of purpose. Clean code is focused. Each function, each class, each module exposes a single-minded attitude that remains entirely undistracted, unpolluted by surrounding detail, right? Uh, so like, and like I compare it to like our day-to-day habits. Like having good habits means that whenever you're doing your work, you're focused, right? You are focused in your work. And not having great habits is that you are easily distracted by your phones or other things, right? When you're doing work. So similarly, I see like like there is a lot of these cross relation between things, and that's basically what like I felt really good about this definition, that clean code should be focused, that when you are reading it, its intent is what it needs to do, rather than having those muddled multiple intentions which are hard to understand. So yeah. Okay, then this other thing that and basically it goes into actually this section why clean code is important. So in an organization that we will see that most of the time we will be spending in reading code versus writing code, right? We spend around 10:1 time, whereas 10 time goes in reading the code and 1x time goes in writing code. So having optimized, so we should be optimizing for reading, not writing, right? And basically if we are writing code very quickly and which is very bad, so we have optimized it for the write, that write was fast, but then the read will be slow because next time when you have to look back again at the code, it will take more time. Whereas while writing, if you are spending little bit more time, right, then you are basically optimizing for your read. Your reads will later be much faster. You will be able to understand your code easily, right? So yeah, so let's pull this here. Okay. Yeah. And I think, yeah, then somewhere in the book, they also mentioned about this Boy Scouts rule that they teach them that leave the campground cleaner than you found it, right? So similarly, if we apply that same principle, that if we leave the code, whatever code we are reading, if we leave it a little better than what we have read, then that's a good habit. Yeah. Okay. Like in this section now, if we have time, we can look at what some of the writers have written the definition of clean code, but let's do this after this part. But before we go there, any other thoughts or any other definitions which someone liked a lot?
I personally like the Unix philosophy, like do one thing well, make it so beautiful that everybody talks about it. And so this was like it's coming from Unix, but it's kind of applied right now to all the architectural principles as well. Like you see a shift from monoliths to microservices, and this was the thing that was, this was making this change. Do one thing well. And I think it was mentioned in the book somewhere. I was reading about it. So this is one of the things that I personally wanted to put forward.
Yeah,
This is very important.
definitely.
Yeah. So basically, our functions, they should do one thing well. Like they shouldn't be messy. So it like obviously you can translate it as programmers, but it applies everywhere. Like it's in architecture, it's in it's everywhere, and it makes system scalable. Like this small thing makes system scalable at every point. Yeah. This one.
Yes, super great point. Yeah. And actually, this point was mentioned so many times in designing data intensive applications. Like, if you guys remember, like, he has so many times talked about this Unix principle of doing one thing well. And yeah, that's actually a great principle. Okay, so Nishit had added something. One more thing in definition of clean code is that it seems like the author is cared for the code. Oh yeah, definitely. So yeah, one more definition which was given about clean code is that when you are reading a clean code, you will feel like that the author of the code has actually cared about writing that code. And uh, and usually we do not care for code quality when we are in deadlines, right? So yeah. Okay. So now let's see. Now let's this part how we actually write clean code, right? So then writing clean code, right? So what author has said is that clean code is lot like painting picture, right? So when you see a picture, right, most of us can tell whether that painting is good or not so good, right? So like somehow it's like that art that we know it, but to actually get into that art, we actually need to know those techniques, and those we have to practice those techniques. And for some people it is inborn, right? So some people maybe inborn they are good artists, right? So similarly, some people inborn they have this habit of keeping things clean, and so that would be in turn like maybe into writing clean code and everything is clean, right? They're super careful about it. For some people it might not be a habit, and so they would have to develop that habit, right? Like similar like paintings as well, that if like you are naturally not so good at it, you can learn it, right? And you can develop those skills. So yeah, then now later in this book we will see like what are those techniques that will actually help us write clean code. Cool. So that was about like how we can actually go about writing clean code. So yeah, that's I think that's these are the main points for today's session. So what I'm thinking of is uh, like I will probably put some of the definitions here so that we can just look over those definitions of what is the definition of clean code, and we can uh, just think about them and comment about them. Okay, so let's start with this is the definition of uh, Straub, Stroustrup, the inventor of C++. Uh, so when the author interviewed him, so he said that I like my code to be elegant and efficient. The logic should be straightforward to make. The logic should be straightforward to make it hard for bugs to hide. The dependency is minimal for ease maintenance, error handling complete according to an articulated strategy, and performance close to optimal, so as not to tempt people to make the code messy with unprincipled optimizations. Clean code does one thing well. Then this is another definition. Clean code is simple and direct. Clean code reads like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control. Yeah, and there are many more. I think we all can read them. I'm just trying to find that exact definition uh, which Nishit has mentioned about clean code is something that feels like author has cared about. Pretty much you can call. This by Michael Feathers. Okay. Michael Feathers. Yeah. Yeah, even Nishit, yeah, I even like this definition a lot. So yeah, so he has mentioned, I could list all the qualities that I notice in clean code, but there is one overarching quality that leads to all of them. Clean code always looks like it was written by someone who cares. There is nothing obvious that you can do to make it better. All of those things were thought about by the code's author. And if you try to imagine improvements, you are led back to where you are, sitting in appreciation of the code someone left for you, code left by someone who cares deeply about the craft, right? So, I mean, as you can see from the intention that like a lot of these things are subjective and it's like art, that you can tell whether code is clean or not, and there are techniques that you can learn, but also like these things, there is not like absolute rules about them, and these things, they could, like, people could have different opinion about them. As long as they can justify their opinions, as long as they can justify why they have done it and they have given thought on it, I think it's good. If they have not thought on it, if they have hastily done it just to meet the deadlines, then that's something that's a red flag and that should not be done. Okay, so I think that's all from my end today. If there's anything else we can discuss, else next week, let's continue the discussion next time for the next chapter, which is actually naming. And we can see that naming and function, either we can cover in either one session or different sessions. So yeah.
So next session, Abhishek, we have book club, right? I mean, sorry, the paper, right?
Yes, let me stop the recording and then we can discuss about that. Stop recording.